Hi, I'll try to keep this kind of quick. This is super important, this statement right here. So we're dealing with finite sets A and B. The number of elements in A or B is equal to the number of elements of A plus the number of elements of B minus the number of elements in A intersect B. And if we have an example, I think it could make more sense. Let's say we have 14 elements here. This is number of elements, 2 here and 8 here. And we want to find out how many are in A union B. So that's all of circle A put together with circle B. Everything that's in those two circles. So looking at it, it looks like A union B should be these three numbers added up. It should be 24 elements. But according to the formula, the number of elements in A is 14 and 2, so that's 16, plus the number of elements in B, that's 8 and 2, so that's 10. And then some of these elements got counted twice. These that are in the intersection, they were counted twice, so we want to subtract those off. So if we do that 26 and take away 2, then we get the 24 that we got when we just looked at the Venn diagrams and added those pieces up. Now I'd like for us to look at this word problem together. The results of a survey of visitors at the Grand Canyon showed that 25 speak Spanish, 14 speak French, and 4 speak both Spanish and French. How many speak Spanish or French? So if we do the number who speak Spanish or French, according to the formula, that would be equal to the number that speak Spanish plus the number that speak French minus the number that speak both Spanish and French. So that's how that formula is going to work. We don't know how many speak or, that's what we're trying to figure out. But we do know the number that speak Spanish is 25. And the number who speak French is 14. And we know that there are 4 who speak both. So 25 plus 14 is 39. Take away 4 is 35. I would just like to prove this with a Venn diagram real quickly. And when we do a Venn diagram for a set of data, we probably want to start with this both number. So the number that speaks Spanish and French, this is my Spanish circle, this is my French circle. That would be the intersect. There are 4 people that speak both, so we want to put them in the middle there. Now this circle on the left is all the people that speak Spanish, and we know there are 25 of them. Well, I already have 4 on the intersected part, so if it's 25 total, that'll leave 21 for the rest of the circle. We'll do the same thing for French. We know there are 14 people who speak French, but we already have 4 on the intersect. So how many are left out here on this part of the circle? 14 minus 4 is 10. And then you can just add up all these people that are listed here, and you get 21 and 4 and 10, which is 35. That's why this little formula makes sense. Now we have a new idea. It's called the difference of two sets. And here's the definition. The difference of two sets A and B, symbolized by A minus B, is the set of elements that belong to A but not to B. So it's almost like we're going to take set A and we're going to subtract B's elements from it. And the ones that are left in A, after we've done that subtracting off, they are the ones that are in the difference. So to help that make sense, we have an example 9 here. We've got the universal set defined that way, and A, B, and C are defined. And let's answer a few questions. So part A, we want the difference of A and B, or A minus B. So what we want to do is we want to take set A. Our answer is set A, but we're going to take off any elements from A that are also in B. So B has little a, but it's not an element of A. B has little b, which is also an element of big A, so we'll take B off. B has little d, which is also an A, so we'll take it off. H is also an A, so we'll subtract it off. And I is not in A. So the answer of A take away B is whatever is left in A once we have subtracted B off. So there we go. Next, we're going to look at A minus C, the difference of two sets A and C. So same idea. We're going to start with set A, but we're going to subtract off set C. So C's got B in it, take that off of A. C has E, take that off. And C has G, take that off. Our answer are these things that are still there in A. So it's B, F, and H. C is A prime minus B. The difference of the elements in A prime and B. What I really want you to do is I want you to go to the side of your paper and write out the elements that are in A prime. Don't try to keep up with it in your head. So A prime says what elements in the universal set. So look at the elements of A and take those off of you, the universal set. What's left in the universal set if we remove set A from it? So we have A, C, I, J, K, I think. And then now we can look at A prime and we can take off the elements that are in B. So we have to take A away, H, I. Those are the only two that I had to subtract off. So what's left in A complement is C, J, and K. Last one. Actually, I think we will skip that. Last idea is the Cartesian product idea. And Cartesian product, you might have heard of the Cartesian plane before, or the fact that's our XY plane, or the fact that coordinates are called Cartesian coordinates, and those are all named after the mathematician René Descartes. And same thing about this Cartesian product. He did a lot of work with coordinate pairs and things on the graphing. Okie dokie. So Cartesian product is the set A. The Cartesian product of set A and set B is symbolized by A cross B, and that is read A cross B. It's the set of all ordered pairs in the form AB, where this first element comes from the first element in the cross, and the second element comes from the second element in the cross. So I have this great example down here, example 10, last one. A is orange, banana, apple, and B is 1, 2. And A part, they want us to find A cross B. Said the Cartesian product is the set of all possible ordered pairs. So these are ordered pairs, and it's in a set. What I would do, since A is first, my x coordinates are going to come from A. So it's going to be like orange, comma, 1. And then I'll do orange again. And I'll take the other element in B. So orange, comma, 2. Now we're done with orange. So our next ordered pair will be banana and the first element of B, and banana and the second element of B. Done with banana. So last we'll have apple 1 and apple 2. And this is just the Cartesian product. So if you wanted to do B cross B, then you would be making ordered pairs with B and with B. So you would do like 1, 1 and 1, 2, and then you would do 2, 1 and 2, 2.